Up now.
Okay, thank you, Jason. And I really wish I can get double paid, and one from OU, the other from OSU. So, long story short, I just joined OU in 3 months, 3 months ago, and my background was in civil engineering, water resources management, and hydrology, and all the PhD work and the research around reservoirs. So you see the title here is reservoir operation in the context of water energy nexus. And this figure shows a global overview of the older reservoirs around the world. There are about 500,000 or even more reservoirs. And a lot of those developing countries, such as my home country, China, they are still build thousands of reservoirs each year. And in the US, pretty much the major construction area has passed. And right now, we are thinking how to efficiently operate those reservoir systems, those facilities to reach higher security, higher sustainability, higher resiliency against the extremes. And so reservoir has been really a major infrastructure human built to manage water. And also from the regional level, state level, people use reservoir to transfer water from all the wet area to dry area, such as California, which I got my degree. And also in my home country, the Grand Water Transfer Project are moving water to the big cities to deliver drinkable and industrial water. Okay, and if we look at more detail in a finer city level, reservoir really provide our buffer to against the extremes, like those Hurricane Harvey last year, and during this Harvey time, there are a lot of flooding. However, there was a piece of news that U.S. Army Corps has intentionally opened their reservoir gates to release additional water, which caused additional like 5,000 houses flooded. And if you go to Zillows, look for those housing prices, real estate price around those two reservoirs near Houston, you will find after the Harvey events, the price has dropped a little bit. And I think it is an indication that those areas used to be a really great place to live. However, right now, people are thinking whether we got enough protection from the reservoir, whether we are in a flood zone of reservoir at the downstream or at the, near the reservoir. So reservoir at the regional level really provide our last defense to all the potential flooding, okay? And this statistic here is from Department of Energy. And instead of the water benefit, reservoir provide all kinds of hydropower benefits, and it's energy in the context of energy. The good thing about hydropower, it is you can really turn on and off those gates quickly instead of those those nuclear plants or coal-fired plants, which you cannot really turn in an hour or so, okay? And basically this slide, I stole this slide from Department of Energy again. Last year when I was in a science review meeting, they really think the future of hydropower and the reservoir really based on 3 strategic pillars: optimization, growth, and the sustainability, and how we project the future given the optimal allocation of resources and of water and energy of the existing system. And what we propose here is really an integrated framework that all the way consider hydrometeorology forecast on the top as a driving force, and run that to hydrologic model, and then routed to reservoir models, and to see what will be the optimal solutions for all kinds of benefits. Agriculture in the context of food, hydropower in the context of energy, and the drinking water, industrial water uses in the context of water. So it's reservoir is a direct link to those water, energy, food nexus. And what we propose here is really a combined solution with the optimization, algorithm development, modeling approach, and decision making, how to help decision makers or utility companies to use those advanced tools in their daily work. As I'm running out of time, and since I got double paid, so I grant myself a minute. And so basically, for each of the content here, optimization, of course, reservoir is a multi-objective subject. You have to consider flood, you have to consider your spill, your other benefit in a multi-criteria context. So as an example here, this is a Grand Coulee Dam in Oregon, and if you really spill your water, you cannot recover that to regenerate hydropower. And modeling, basically, there are two types of approaches: physical-based, to build the water balance equation. And if you look into the literature, there are more and more work to use AI and the data mining, those deep learning algorithms, to build the statistical models to help with the decision making and how to predict the outflows or the inflows of reservoir. And the last, after my degree, I worked a couple years with the consulting company serving for Bonneville Power Administration. And they have a cascade reservoir system, very complex system with the different size of reservoir, all the way from the top with a large reservoir, Grand Coulee, and all the way water routed to the city of Portland, which at the bottom is a Bonneville Dam, is a very small reservoir. All the time for the water routing from the top to down is about a day. So they have to use a lot of optimization techniques and decision-making platform to make the releases of each reservoir at a certain time. And what we build is a complete structure with all the algorithm and the model development. And the last, I want to thank Jason to grant me a time. And and what I want to say is Water Oil Day is really a good opportunity that connect with the faculties, researchers, and with the public utility company, this stakeholder. And we imagine that it is needed to build a foundation of knowledge that is positioned in university, however, with the collaboration with all the agencies and partners, like those folks sitting right here. Okay, thanks, Jason.